Hi, my name is Diego Rivera, and I'm an environmental earth and soil science major for the class of 2019. Today we'll be working through problem number 4 from chapter 4.3 in the general chemistry workbook. You should begin by working on it yourself and trying to get the answer. Pause the video now until you're done solving it, and we'll go through it together. So basically the question reads, copper reacts with dilute nitric acid, and they give you the formula. And they tell you that a 3.045 gram penny is dissolved in a small amount of nitric acid. This solution, which is what you get with the products, is then added to 50 milliliters of water. And the question asks, what is the molarity of the copper nitrate in this solution? I would start off by basically picking out the important parts of the problem, which is like all the numbers and the different chemicals. So you have your penny, they give you is 3.045 grams, and it's pure copper, so you're basically dealing with this part of the equation with this guy. The water is not a part of the reaction itself. It's something you need to go back to later once you're done with the first parts of the problem. And it's asking you for the molarity of the copper nitrate in the solution of water at the end. Okay, so I took the important parts of the question and put them off to the side. So we have your copper penny, pure copper, 3.045 grams. Your end goal is the molarity of the copper nitrate in your 50 milliliters of water. So these are all the important pieces that are going to help you solve the problem. So the end goal is moles per liter of copper nitrate. So we're basically trying to get the moles of the copper nitrate. So they give you 3.045 grams of copper to start. So that's your starting point. You're basically going from grams of copper to moles of copper nitrate. Since we're going from grams to moles, we can put the conversion in for the molecular weight of copper, which is 63.546 grams for 1 mole. And you calculate that out, and you get 0.0479 moles of copper. Because we are comparing moles of copper now to moles of copper nitrate, which is the end goal, you're going to take the mole ratio. So you're going to take, you're going to take the moles of copper that you have and plug it into the mole ratio to get your moles of copper nitrate. Luckily, the mole ratio is 3 to 3, which simplifies down to 1 to 1. So basically you have the same amount of moles of copper nitrate as you do moles of copper, because that ratio is 1 to 1. So you have 0.0479 moles of copper nitrate as your products. Now that we have our 0.0479 moles of copper nitrate, the next step is pretty simple. The problem tells you that all this mixture is diluted to what amounts to 50 milliliters along with the water. So you don't have to worry about the amount of copper nitrate or the amount of nitric acid involved in this reaction. You just know that the entire mixture results in 50 milliliters flat. So you have 0.0479 moles of copper nitrate. So you're looking for molarity, which is moles per liter. So the next step would be to divide 0.0479 moles by 50 milliliters. That equals 0.000958 moles per milliliter. So from there, you're going to need to multiply that number, or you're going to need to do dimensional analysis to get moles per liter, which is what molarity is. So you got to take 0.000958, and you just multiply it by 1,000. And so your molarity is 0.958. So the answer to the problem is 0.958 moles per liter of copper nitrate in that 50 milliliter solution. And so to recap, the key things that helped me solve this problem is definitely know what your goal is. So we know that our goal was molarity of copper nitrate, and know where your starting point is. So they gave us a penny that's pure copper, 3.045 grams, and from there, at least with this problem, a lot of it was dimensional analysis and knowing your ratios. And as long as you have a starting point and an ending point, you can put together the puzzle and figure out what the intermediate steps are to get you to your goal.